Welcome to Lab 3, Porosity Determination using the Helium Porosimeter method. Porosity is defined as the pore volume over the bulk volume, and to get it in a percentage, you times it by 100. This porosimeter uses principles of gas expansion as described by Boyle's law, which we all know as P1V1 equals P2V2. A known volume of helium gas at a fixed initial pressure is isothermally expanded into a unknown void volume. After expansion, the resultant stabilized pressure is measured, that pressure being dependent on the magnitude of the unknown volume. The magnitude of the unknown volume may be calculated using the ideal gas equation of state, which is P1V1 equals P2V2. Now, we use helium for this lab for a variety of reasons. First, it can be modeled as an ideal gas for most pressures and temperatures. It consists of small molecules which will penetrate the tiny pores in the rock, and it has a low mass and therefore a high diffusivity, and can be used to determine the porosity of a low permeability rock. This is the front panel of the Helium Porosimeter Porg 200 made by the Core Lab company. We see here that we have a pressure gauge, a regulator which controls the pressure gauge, the outlet valve which connects to the matrix in our sample, our readings, and a valve 1 and valve 2. The reference pressure is pressured to be around 100 psi, which comes from over there, and is expanded into a matrix cup sample holder containing the sample to be analyzed. A second pressure is read and used to compute the unknown volume. The following equation is often used to derive grain volume. The first thing that we're going to do in our procedure is measure the volume of this core sample. Because it has an irregular shape, we're going to take the average of 3 different measurements. So we're going to measure 3 different times on the top and measure 3 different times on this, and then average those to find the volume of the sample. The next thing that we're going to do is zero our pressure transducer. We're going to turn off our helium source, open valve 1, and then turn valve 2 to expand, and that will open the matrix cup. The pressure reading on the digital reading should be showing 0. If it's not 0, repeat the procedure to make certain that all the pressure has been released. If the readout value has decreased but is still not 0, adjust the 0 adjustment screw until a 0 reading is obtained. Since ours is already 0, we'll move on to the next step. Now we're going to determine our standard curve. First, we're going to connect the matrix cup to the instrument. We're going to place a reference disc starting from smallest to biggest inside the reference cup and connect it to our piece of equipment. The matrix discs and then the combinations of matrix discs that you are going to be using will be found on the Excel spreadsheet in Blackboard. We're going to put in disc number 1 and then place it evenly and close the lid. Make sure that your valve on the back side is turned off. And now we're going to turn V2 to the vent position and V1 to the on position. Wait until the pressure is stabilized and then record the upstream pressure. This is P1. Then we'll turn V1 to the off position and turn V2 to expand. Wait until the reading has stabilized and then record this as your P2. Then you'll turn V2 to vent, switch the valve on the back, open, and take out your sample. And we'll repeat this process with all the different sample sizes and a combination of them. So after we get P1 and P2 from all of our different samples and the combinations, we're going to plug it into our Excel sheet, which will give us a standard deviation curve. We'll fit a line of best fit to that curve, and that will give us different coefficients that we'll use later. After obtaining that, we're going to use the core sample. We're going to place this in our matrix and make sure it's equal on both sides, and then tighten the lid. Make sure that the rear valve is turned to off. We're going to turn V2 to the vent position and then turn V1 on and record pressure 1 for our core sample. Once that is stabilized, record that, and then we'll turn V1 to the off position and V2 to expand. Once that is stabilized, we'll record that as our P2. You will plug P1 and P2 obtained from the core sample into your Excel spreadsheet, and using the relationship with the standard curve, determine the grain volume of the core sample. The core sample at the beginning, and Excel told us the grain volume. With those two parameters, we'll be able to calculate porosity. Now you tell me, is that the interconnected porosity or the total porosity?